Let's go. Yeah. For those of you that want to know what we're all about, it's like this.
I'm Justin Eckstein. I'm a senior computer engineering major.
I'm Greg Miller. I'm a computer science major.
I'm Derek Coleman, and I'm a senior computer engineer.
And we're the Feather Rufflers!
The first thing that we want to do with this debugging process is reflow some of the parts on here, and there are about 80 parts, and they're all really tiny. So what we're going to do is take the soldering iron and use some flux, and we're going to reflow the parts and make sure that they have good contacts with the board so we can test voltages and currents and things like that. So the first thing we're going to do is use this flux, and we're going to put it on the part that we're going to be testing here, and we're going to reflow it. And the flux actually helps the solder heat up faster so that we can more easily reflow that part. So I just put a little bit of flux on there. I'm going to use this soldering iron here. I'm going to reflow some of this solder. And the part came off. Okay, so it looks like we have the part back on there, and it's been reflowed. So now we can go ahead and use this multimeter over here and this DC power supply, and we're going to supply it about 4 volts. We have a voltage, 4.1 volts. We have a voltage divider on here, and so all of our high pins should be about 3.3 volts, and this one that we're testing is supposed to be 3.3 volts. So we'll go ahead and test it with this multimeter, and there we go. We've got about 3.34 volts, which is what we're looking for.
This here is our third iteration that we just sent to get fabricated, and this took quite a bit of time to make. But essentially this red layer here is the top of the board, and then everything in blue is the bottom of the board, and there's various other layers, and these are all the different schematics that are a little bit easier to understand what's going on. And then these get, after we make these schematics, we have to go implement the wiring of them in that board you saw. So this becomes this. The GPS is this big purple thing. That's the GPS. This is the MCU. And over here is the antenna. As you can see down here, we labeled what version of our Pheasant Tracker it is by the Feather Rufflers. Derek Coleman, Justin Eckstein, Greg Miller, University of Nebraska-Lincoln. This is the JTAG header where we'd be able to program it. Over here is where we would hook up the solar panel and the battery. This is the on-off switch. And then these are some debug lines we included. That way we would be able to hook it up to UART or SPI and be able to communicate, listen to it from the computer.
Alright, now we're going to show you a demonstration how TinyOS works. TinyOS is what we're going to be using to write our drivers and program our boards. I'm going to show you a demonstration of a little test to show you how we get the program running on a test board. So right now you can see that it's not blinking, nothing's going on. Make Micah install 0 MIB. Alright, now it's going to start compiling. It's going to program it onto the board. And I'm going to show you the board here in a second, showing that it's actually blinking now. And there you go.